Hello friends, and welcome to this video in which we talk about how can we convert a definite integration as a limit of sum. Now clearly when we say definite integration, let's say this is a to b fx dx, we mean area under the graph, right, of the function y is equal to fx between the limits x equal to a and x equal to b. Now clearly, can we convert this into a limit problem? Yes, we can. So let's see, this is x equal to a line, this is x equal to b line, this is a function y is equal to fx, and we need to find the area under it. Okay. So what we do is we divide this divisions into n equal parts. So basically from here to here it is b minus a, and if we divide this into n equal parts, the width of each division, let's call it by h, would be b minus a upon n. Call this as h. So if this was a, this is a plus h, a plus 2h, a plus 3h, all the way till this will be a plus n minus 1 into h. Now clearly we can divide this area in the form of the vertical rectangles. So this is one area, this is second area, this is third, this is fourth, and so on. The width of each rectangles are same, so we are just finding the areas of these rectangles, right? All these rectangles we are trying to find. So let's say the area of the first rectangle, so it is basically a1, it is height into width. So height is functional value at x equal to a, into width we have defined as h. a2, this would be functional value at a next point, the next point. Now this was x equals a, this is x equal to a plus h, this is a plus h. So the height would be the functional value at a plus h times h, which is the width. Now clearly we can do this for the n, and the last rectangle also would have the area. This would be having the area, an would be having the area f of, this will be a plus n minus 1 into h. This is the functional value into h. Now clearly there is a problem over here, because when we are finding this area there are some errors. So these are the errors. So if we can minimize those errors, right, and eventually make it to 0, then we are done. Then we get the area under the curve, which is given by this definite integration expression. So what we can do over here, now what we can do is we can say that these n divisions, let's make it infinitesimally very small, which means let's say n tend towards infinity. So each division becomes very small. So if each division becomes very small, then the error would also minimize. Example, if you had only two divisions between the function, the error was huge. But if you divide this into three parts, then the error would also minimize, the errors would also decrease. And if you make it n tending towards infinity, then you are left with no errors. So can we write this expression as a summation expression on which we can put a limit? Yes. So first let's add all these area. So summation a1 a2 till an, this we can write as what? Summation r going from 0 to n minus 1. This value would be functional value at a plus r h into h. And if we put the limit over here, let's say limit n tending towards infinity, we are done. So clearly this expression a to b we can write in terms of this limit. Now the special case, if you assume, let's say a is equal to 0 and b is equal to 1, so h would be 1 by n. So under this things, what happens, this integration, right, this we can write as what? This will be 0 to 1 f of x dx, right? This I can write as what? Making a corresponding change in the limit expression also, we have n tending towards infinity, summation r going from 0 to n minus 1. It is functional value, what is a is 0, h is 1 by n, so it becomes r by n, and clearly h is also 1 by n. So we can see a shortcut over here. that if you want, I'm using a highlighter just to make point bit more clear. So if you need to convert, say, a limit expression into a definite integration expression, what we can do, so r by n becomes x and a small infinitesimal dx becomes, this is derived from 1 by n. So if we do two things, r by n we claim as x and 1 by n we say as dx, clearly we can convert a limit of a summation problem into a definite integration problem. In the next video we will try to see some more workable examples on this particular aspect of theory. Thanks for watching this video.